Hello, Chem student. Today we'll be talking about 14.1 type of mixtures. So in general, there's usually two category of mixture. Heterogeneous means that the part of the mixture are not blended together evenly, or there's distinct noticeable differences in the part. With heterogeneous, you can see different layer, different chunk, different pieces. Within heterogeneous, there's one main subcategory called suspension, where it usually is liquid mixed with solid or gases mixed with solid. And if the mixture is left undisturbed for say an hour or so, no more than that, you can start seeing settlement or separation or layers, and that's called a suspension. So here you will see example of suspension that existed in the past. If you look at the rock on the left, even though that took a lot longer than an hour or so, but after when it's done, you can notice that there's chunks that's darker and chunks that are lighter in color. With the sandstorm on the right, what happened after the sandstorm is you will have all of the solid in the sandstorm, aka the sand, will fall to the ground and covers everything, and then the gases or the air will just still be in the atmosphere. So those are two examples of suspension. One very quick, the sandstorm, and one takes quite a bit longer. So here's another example of suspension. If I take flour, which is a solid, and add some water to it, and I shake it up, within a short amount of time, you can see the bottom already separate into a layer. But if I leave it for another half an hour to an hour, you can see on the right, that is a clear separation of the water and the flour. Now there's still a few tiny little pieces of flour that's suspended in the liquid layer, but the majority of the bigger grain have already settled down. On the right, we have a glass of milk that has already separated into cream and skim milk, and you can clearly see the layer of fat has floated up to the top, whereas the protein, the water, and the material is in the skim milk in the bottom part. So both of those, again, are suspension. So within mixtures, sometimes the property of the material combined together behaves in a very unique way. So for example, most soil are solid, they don't flow. Water is a liquid, they flow. And when you mix water and soil together, it doesn't really flow at first until it gets very watery. But even if it's not that watery, it can flow given that if there's a force acted on it. So for example, on a wet, rainy day, your houses still can sit on the hillside just fine. But if there's an earthquake or there's a lot of vibration, the combination of water and mud together now can start flowing, and you end up with a mudslide. And that's called thesotropy. So when substances that usually are pretty solid start to flow and behave like a fluid when there's a force or an energy added to it, we call that again thesotropy. So toothpaste, for example, if you put some onto a table, it doesn't flow. But if I take my hand and put a pressure on it, it will flow left or flow to the right. When it's in a tube and you hold it upside down, it doesn't really flow out. But when you squeeze it, it flows pretty well. Okay. Next category of mixtures are called colloid. This is where the particles are not as big as a suspension, so they don't really settle down or settle out very much. So in the opal on the left or the piece of stained glass on the right, the material that makes it opaque is obviously big enough to block light, but then it's not big enough to settle very, very quickly or fast. And you don't really see very noticeable grain of different material. So the blue glass on the right you see is just blue. You can see that it blocks light because it has a shadow. But when light shines to it, it causes it to scatter. That's why you see the orange in it. Same with the opal. Okay, and the effect of causing light to scatter and making it feel like it's glowing is called the Tyndall effect. If you can see the actual animation on this slide, if you will put it on presentation, you will see that the tiny little particle on the left is moving randomly. So this is like sugar in soda. It is randomly moving all the time and it never really settles. Whereas on the right with the bigger yellow that represent like fat in milk, if you let it sit for a while, because that fat is much bigger than the rest of the tiny little gray water molecule moving around, it will float in one direction. So please do the slide in presentation mode and you can see that. So the random motion of the liquid or the gas in a liquid or gas based mixture is called Brownian motion, and it causes things to be naturally stir up quite a bit unless the particle is too big and sink to the bottom, or in this case the particle is too big and is much lower in density like fat, it'll float to the top. And that's the picture on the right. So once again, with Brownian motion, you just need to start getting the blood out from the arm of this gentleman into the machine for it to clean out the blood. You don't need to stick needle all throughout his body, just in the PICC line in his arm right here. And the natural flow of the blood in your body pumped by the heart and the random motion of the blood will eventually clean out most of his blood within a couple hours. Okay, last is a mixture where the particle are mixed so well, that means mixed evenly, so well that you cannot see one part different from another. And if it's a liquid or a gas-based mixture, most of the time, even if it has a color, light can travel through it very, very easily and it doesn't glow. Okay, that's called a solution. Within the solution, there's always two main parts. The part that is the majority of the mixture is the solvent, like in the case of air, it would be nitrogen. And anything else that's dissolving it, in the case of air, it will be oxygen, carbon dioxide, other noble gases, and some air pollution. Okay, so the solvent is the bigger quantity or the main part of the mixture, and the solute is the smaller quantity. So in seawater, for example, the solvent will be the water, and salt would be the solute. Unless it's dirty seawater, then it's not a solution anymore. That would be a colloid or a suspension if it's cloudy or opaque. So here are just some example of alloy, which is a solid solution. Brass is a mixture of different metal. Aluminum alloy is also a different mixture of different metal. Or very, very expensive headphone, the magnet in it still is a mixture of different metal. So alloys are solid solution of metal with something else. Okay. So good alloy needed for things like knee and hip replacement, or for making cars. You can see cars in the old day, the design is different, but also the metal is different. So when you crash a much older car from 40, 50 years ago versus a car now, the damage is quite a lot more in the older car because the steel, the mixture of carbon and iron are not blended together in a unique way that gives it the optimal strength. Okay, so once again, how do you make a solution? You dissolve a solute in a solvent. If it's able to dissolve and it blends very, very well, we call that soluble. But if it does not dissolve, we call that insoluble. So sand is insoluble in water, but salt or sugar is soluble in water. Okay, so here's just an example of insoluble, mud and water, and then soluble, salt and water. Okay, now when you have two liquids mixed with each other, we use a specific word instead of soluble and insoluble. We call it miscible or immiscible. Like alcohol and water mix well, they do not separate into layers, so that's miscible. And alcohol mixed with, for example, oil do not mix, they'll separate. Or just like oil and water, they do not mix, we call that immiscible because it will separate into layers. Okay. Example is Italian salad dressing. The oil layer do not mix with the vinegar layer very well because vinegar is mostly water, so you do have to shake it up. And this is also a suspension because you can see a lot of the solid like the pepper, the garlic and stuff sinks to the bottom. So here's once again example of suspension, colloid, and solution. On the far left, you have to something that's very, very close to a solution. It's transparent, light can pass to it. The middle one, you can see the Tyndall effect. It glows the most, and that's a colloid. And then a suspension, light doesn't pass to it. It doesn't seem to glow very much. And you can notice the bottom part tend to be darker because there's more of the particle beginning to settle, and that's a suspension. Okay. So here just showing you that the different size of the particle, usually the bigger it is, the more likely you will have a suspension, and the smaller it is, the more likely you have a solution. So 200 nanometer, light is pretty much opaque. If you let that sit for about an hour or two, you will see a layer in the bottom. At 2 nanometer, the particle is so small that the Brownian natural motion of the liquid, aka in this case the water, will dissolve it so well that you cannot see the particle at all. And you don't have to shake it or anything. So for the homework today, please read this and answer it in detail and explain why for some of them.